Hi, my name is Khaled Elawad, and I'm a scientific solutions consultant here at Synthace. So today I want to talk about using Synthace to execute RoboColumns experiments, which are small-scale column chromatography experiments that can be automated on Tecan liquid handling systems. In Synthace, we make use of a graphical user interface like the one that you're seeing here, and we leverage these building blocks, which we call elements, to describe different parts of our process, different materials that we're using, and then we link these elements together to describe a workflow, which can characterize an entire experimental method. So zooming in here, you can see that each one of these building blocks opens up and allows us to parametrize the different aspects of our experiment. For example, where we want certain materials to go and how we want to use them in a particular step of the process. We can even describe liquid handling conditions and factors that go into driving our automation or characterizing different parts of our process. This graphical user interface makes it a lot easier to make changes and do complex methods that have multiple different parameters or multiple different factors in the same experimental run. The great thing about using Synthace as a digital experiment platform is it helps us better leverage our automation tools. So I can build a method in this graphical user interface and transcribe it into a particular piece of automation that I have in the lab. So for example, if I want to run this particular method on our Tecan Fluent, I can select that from my device library, let Synthace know what the configuration of my instrument is and how I want to allocate labware, even select labware from our labware library specific to that instrument. Synthace then does all of the hard work by transcribing our method into a set of executable automation instructions for that particular instrument. I don't have to write any scripts, and if I want to make changes, it's as easy as making a few simple clicks and reflecting those changes in a simulation that Synthace generates for me that I can then use to drive my experiment on a Tecan instrument. What Synthace is doing right now is calculating all of the individual volume transfers, all of the complex preparation calculations that need to be done, as well as generating the device-specific liquid handling instructions to drive this execution. That'll all be reflected in the output of this simulation, where we can see in silico a graphical representation and overview of my experiment. What's the labware that's going to be required from me? What are the reagents and the associated volumes of those reagents that I'll need to execute this? And what instructions do I actually need to carry out in order to execute this on a particular piece of hardware? The visual preview is one of my favorite parts because it actually shows me everything that I need to do as an experimentalist in order to set up this run. Where do I need to allocate specific reagents? Where do I need to allocate specific pieces of labware? And I can see that visualized and represented on my specific Tecan. I can even walk through this method step by step and see all of the liquid handling transfers that are going to occur. I can see the flow through of materials through my chromatography columns and the subsequent collection of fractions that occur after. I can even jump to different parts of the process, see the collection of my fractions. And if I zoom in here, you can see that Synthace digitally carries forward all of the information about my samples and the materials involved in the process. Any metadata associated with the experimental process is going to be brought forth by Synthace. Once I'm ready to go, I can simply schedule this for execution in the lab, or I can jump back into the method and make changes if I'm not happy with something. For example, maybe my Tecan Fluent is occupied today, and I want to run this exact same method on a different instrument that I have available to me. It's no problem. All I have to do is simply select a different instrument. Let's say my Tecan Evo system, describe how that system is configured, maybe select some relevant labware for that system, and then I'm good to go. Synthace is going to recompute and retranscribe that method for execution on a completely different device, but it's the exact same method that I've described here. Jumping into that new method, I can see that it's the exact same, but now it's configured and the instructions are computed for execution on a different device. I can walk through that method and make sure that I'm still producing the same fractions, and then I'm ready to go to execute and schedule this for execution in the lab. Once a run is completed in Synthace, this overview page is going to have a new results tab. That results tab is going to show all of the data collected from our process. So in our RoboColumns purification process, one of the hardest things can be collecting data points on all the different fractions that you've created and then associating those fractions with the samples and all of the metadata about the experiment that you started with. Synthace does this process automatically by ingesting all of that data, automatically structuring and aligning it in a graphical user interface for us to do our analysis and inspection. So what we can see here is our chromatography results from our RoboColumns experiment. In this case, I can set up my analysis. The ingestion of all of the plate reader data and the structuring of that data with the details of my experiment is automated by Synthace. All of this is compiled in a visual user application where I can see visualizations like chromatograms, heat maps for the collection plates that I've analyzed, and even data layered on top of those plates so that I can understand and inspect for particular samples in particular wells, what were the contents and what was the readout that I had. Most importantly, all of this data is pre-structured for me in an aligned data set where the output readings are associated with fractions collected and all the details about those fractions and how they got there. This saves me tons of time in data alignment and structuring when I'm doing my R&D experiments. Synthace's digital experiment platform allows me to describe different kinds of complex experiments and transcribe them easily to the tools that I have in my laboratory without any extra work or automation knowledge. Most importantly, it helps me get more out of my experiments by automatically structuring the data with the details of my experiment in one digital interface in the cloud. This is readily accessible and an unambiguous representation of my experiment for myself and my colleagues.